Hi class, welcome to section 5.7. This is an application to definite integrals, and it's about consumer surplus and producer surplus. So the idea here behind is, again, we're looking at demand versus price, but what we're going to do this time is we're going to draw the curve a little bit differently, in the sense that here is a demand curve that depends, right, on number of items, and as price depends on number of items. So as we said, the more items you're willing to buy, the less the price charged should be. So the demand curve, again, the more we're buying, the less the price per item should get. Okay, this is again price per item and not total cost. So the idea is simply this. I'm going to tell you a story. So pretend that you're going to buy a car, right? And the car, you're purchasing it at $20,000, right? Let's just make up a number. So let's say you buy that car at $20,000, right? But the dealer would have been definitely willing to have sold you that car for $18,000 if you were patient enough to bargain a little bit more with him. So you would have, you could have bought that car for $18,000, right? That simply means, but you paid $20,000. So that simply means the extra $2,000 that you spend is really money in the producer's, or I should say the supplier's pocket. But on the other hand, maybe you had $21,000 and would have spent $21,000 on that car you really liked, yes? But you were able to haggle the price down to $20,000. So that one extra $1,000 that you would have been willing to spend on that car but didn't have to is money, extra money in your pocket. So that's what a consumer surplus versus producer surplus is. Consumer surplus is the extra money you would have been willing to spend on an item but didn't. So now it's money in your pocket and you can spend it on something else. And a producer surplus is the extra money you actually spend on the item that the producer would have been actually willing to sell you the item for less. So that's extra money in the producer surplus, in the producer's pocket. So again, they can do something else with that amount. So the point is that when people are changing the prices in a market economy where there's competition on prices, you can buy it here for cheaper or there for more expensive, and so on and so on. When there's competition, everybody wins, both the consumer and the producer or the supplier, let's say. Okay, so that's what the story here is about. So given a demand function, and here is a demand curve for you, okay? And as I explained, we're drawing the demand curve as a function of quantity. Yes, so X is the quantity, or Q is the quantity, and then the price is what you are getting out of a Y value. So let's say at this price P, the market price is what you spend. So the market price is what actually you spend on the item. Yes. So what the idea is, anything that you would have been willing to spend more but didn't, right, but you bought it at this cheap price, any other item, right, any quantity where you would have purchased at a higher price, all that extra money, right, that you didn't spend is money in the consumer's pocket, right, in your pocket. So the consumer surplus, simply as a derivative, right, is the accumulation, right, from here to here, when what? From zero to this quantity, Q, that gives you the market price, right? The one that you spent, the one that you paid. So it's the upper function. Remember, we talked about areas between functions. So you have to take the upper function, which is the demand function, minus the lower function, which is this horizontal line where Y is equal to P. Yes? Okay. So it's that minus this. The extra money is coming from right here, okay? So it's the integral from 0 to Q. The demand function is the top function, minus the price, the market price, right, is what the price came up at this quantity Q, okay? So we put it in different forms. Now, from a producer surplus, as I said, you spend this much on the item, yes? So that's the quantity that gave us this market price. But they would have been willing to go even lower, but they didn't have to. So all this extra money right here, right, for all these quantities that you spend that they would have sold it to you for cheaper, is money, extra money in the producer's pockets, right? So again, it's this accumulation from here to here. So it's the integral from what to what. The top function is now this horizontal line, y equals to p, minus the supply curve is S of x, right? So from the supplier points of view, right? The higher the price, the more the items sit on the market, right? So the higher the demand, the higher the price. So in other words, the higher the price, again, the more items are being supplied because no one's purchasing them. So the supply curve and the demand curve are always going in opposite direction, right? The more demand, the less supply. The more supply, the less demand, right? So, so again, the integral, simply talking about integrals, that's going to be the top function, which is y equals to p, right? Minus the lower function, which is the supply curve, S of x. Okay, so there's that. So it's the area between the market price and the supply curve. Okay, so all we're going to do is play with these items. Now, of course, the most important part of the story is, what if we put them together, right? Here's your supply curve, yes. Here's your demand curve. Where the two meet is where the supplier and the consumer have agreed upon a price, right? So the price that was spent is the same when the supplier and the consumer agree on the price to pay, right? So really the market price is where the two curves are meeting, right? Anything above that line is the consumer's surplus, and anything below that line is the producer surplus. Okay, all right. So we also call this point the equilibrium point. Okay, because again, is where the two parties met at an agreement, yes. And this price that we are getting out there is called the market price. So the market price is the price that we getting or that we paying at this equilibrium point. Okay, so that's going to come up. Okay, so the following problems, you will see let me just write this down. So you will see for your homework, I'm making you just find the consumer surplus. So the part about find the producer surplus. But what makes the problem definitely more interesting is to look at both parties, right? So it's kind of with doing it both, but as a warm-up, you're going to also have to solve these problems separately. So for the following problems, first of all, find the equilibrium point or the market price. And then use that to find the consumer surplus. And then use that to find the producer surplus. So we're going to basically practice on all of them. So here's a demand function. And again, usually a demand function is one that's decreasing. A supply function is one that's increasing. So as you see right here, the demand is a line that simply goes down with a slope of 30, right, negative 30. And then the supply is a function that goes up, a linear function that goes up with a slope of 15. Okay, so where these two lines are meeting, that's where the equilibrium point is. So all I have to do is set the two equal to each other. So 8800 minus 30x is equal to 15x plus 7,000. Okay, so it's a simple linear equation. We'll get the x's to one side, the constants to the other side, divide both sides by 45. So x is going to come up to equal to 40. Okay, so the equilibrium point is reached when x is 40, right? So that's again the quantity that would give us the market price. So what's that market price? By the way, I could have plugged this value into either one of the equations because we found this value simply by setting the supply equal to demand. So whatever function looks easier to you, it really doesn't matter. So you plug into one or the other, don't need to find both because you're going to get the same value. So 7,600, this is our market price. Okay. So what is the consumer surplus? One more time, I'm just going to call it CS. The consumer surplus is the extra money up above, right? The one between the demand is what the consumer, right, is demanding. And the market price is this line right here. So simply from what we also learned in section 5.6, how would I find this integral? Don't try and memorize. But again, think about the demand is above. Okay, so you know, because you need to know who's above and who's below. So the integral is between the x values from what to what? From 0 to this x value of 40, right? That's the x value we found. Of what? Who's above? The D function, the demand function, minus who's below this line, right? This market price line, which where's the market price line? At 7,600. Okay, so all I have to do is find the integral from 0 to 40. Dx is 8,800 minus 30x minus 7,600. So that's going to be the integral from 0 to 40 of, I'm going to subtract these, so that's a 1,200. Okay, so the antiderivative of this is going to be 1,200x minus 30x squared divided by 2. Between what and what? Between 0 and 40. Okay, so what we're going to do is plug in a 40 into these values, minus, when you plug in the zeros, those are just going to go down to 0. So when you put this number in, I don't really have much room, but I did the math and I came up to $24,000 extra in the consumer's pocket. Now, the producer surplus has to do with the supply function, right? The supplier gives you the supply function. The producer surplus is what's below. So, I don't know if I do have this room. So the producer surplus is this red part here, right? Which is also what? The integral from 0 to 40 of what? The line is up above, so it's the market price that goes first, minus the supply function is the one below. Okay, and again, those are the formulas from the previous page, but as I said, don't try and memorize things. It's much easier to just think about the picture. So 7,600 minus 15x minus 7,000 dx. So that's going to be a 600. I'm just going to go straight for the antiderivative. So that's 600x minus 15x squared divided by 2, evaluated between 0 and 40. So when you plug these numbers in, again, minus 0, 0, those are going to go down to 0. So that's going to be a 12,000. So that's the extra money in the supplier's pocket. Okay. All right, so let's try this one more time with different functions. So same thing. We're going to want to find the market price, so the equilibrium point, and then use the demand function for the consumer surplus, use the supply function for the producer surplus. So I'm just going to draw this. This is a function that crosses, let's say, at 7 and comes down. That's d of x. Okay. The supply function is a square root function that slowly but surely goes up this way. Okay. All right. So one more time, where the two cross, this is going to be the quantity that's going to produce the market price. Okay. So the price versus quantity. That's the graph. Okay. And then again, what's going to be the producer surplus? The producer surplus is everything above. I'm sorry, the consumer surplus is above because it's got to do with the demand function. The producer surplus is what's below because it has to do with the supply function. Right? Okay, so let's find, first of all, where they meet. So let me set these equal to each other. So the first thing we want to do is to, again, it's a radical equation. So with radical equations, we need to square both sides. So when I square both sides, I'll get a 49 minus 14x plus x squared is equal to 4 times x plus 1. So I'm going to get an x squared minus 18x plus 45. Okay, so what I did, that's a 4x plus 4. I minus the 4x over, combined it with a negative 14x. That's a 4, so I minus the 4 from the 49, and I got that. So sure enough, this should here be factorable. Okay, so numbers that multiply to 18 and add up to 45. It's not your usual 9 and 5. They add up to 14, but it's going to be a 3 and a 15. Okay, so we're getting two answers. One of them is 3. The other one is going to be 15. So which one of these does not quite cut it? And why am I crossing again at 15? We can't be crossing down here. So, okay. So this is not it. I don't even know why 15 came up as an answer, because this line is not going to cross up here. But the first one, the 3, is the one that's going to work. Okay. So, let's plug these numbers. Oh, yeah. I know why the 15 doesn't work. Ugh, I'm just brain farting right now. The 15 doesn't work because it's an extraneous solution. I'm like, these don't meet a second time. This is why 15 doesn't work, because 7 minus 15 is a negative 8, right? So when you solve a radical equation, you get what's called extraneous solution. So you always have to check your answers. So 7 minus 15 is a negative 8. A positive square root can never equal to a negative value. So you always have to check your answer. So that's why that doesn't work. Okay, so we have x equal to 3 as our quantity that gives us the market price. How do I find the market price? I plug that value in. So again, you can plug it in here. 3 plus 1 is 4. The square root of 4 is 2 times 2 is the other 4. So whichever equation you think is easiest, that's the one you have to plug the number in. Okay, so the consumer surplus is going to be the integral from what to what? From 0 to, again, the x value. What's the x value you found? That's a 3. Yes, so don't use the 4. That's a y value there in this graph. Of, again, the consumer surplus is the part above. So which one of these two functions is more? It's the demand function. So the demand function is the 7 minus x minus the the market price, right? This is the bar that separates it, and the market price is a 4. Okay, so that's the integral from 0 to 3. 7 minus 4 is a 3 minus x dx. So the antiderivative of this is going to be 3x minus x squared over 2. Plug in a 3 and plug in a 0. When you plug in a 3, it's going to be a 9 minus 4.5, which is a 4.5, okay? And then the other two are going to be minus 0, minus 0. Okay. The producer surplus, just picked it. It's going to be a little bit fancier because of the type of function that I chose for you. It's going to be the integral from 0 to 3 of what? When you look at the producer surplus, it's this red part here. So which one's the above function? It's the market price, which we found it to be 4, minus 2 square root of x plus 1. Okay, so I'm just going to rewrite this to make it easier for me to find the antiderivative. So it's an x plus 1 to the 1/2, right? So the antiderivative of this, the 4, is 4x minus 2 times the antiderivative of x plus 1 to the 1/2 is x plus 1 to the 3/2 divided by 3/2, right? So sure enough, the derivative of the inside would have been a 1, just as if I would have just had an x. Okay, so plug these in between what and what? In between 0 and 3. So I have some room down here. So I'm going to plug in a 3. That's 4 times 3. Minus, remember, to divide by 3/2 means to multiply by 2/3. So 2 times 2/3 is 4/3. Plug in a 3. And we're going to need to put this in your calculator. Now, these aren't all zeros. Be careful. That's a 4 times 0 minus 4/3 again times what? 0 plus 1, which is not going to be a 0 this time, to the 3/2. Okay, so that's a 12, whatever, 4, 2, 8. 12 minus 32 over 3. That's going to be a 0, but that's going to be a 1, right? To the 3/2 is a 1 times negative 4/3 is going to be a negative 4/3. So when you put this all in your calculator, as I said, that's a 12. That's a 32/3, right, from here. Minus a 0, and minus minus turns into a plus, positive 4/3. So put that in your calculator, and you're going to come up with $2.67, or 8/3 or 2 2/3. So there you have it. Again, I mostly picked this problem just to try a different type of function in an integral. Okay, all right. So same story one more time. Okay. And there it is. Find there's the demand function, there's the supply function. Find the equilibrium point so you can find the market price. So I'm going to take these and set them equal to each other. Okay, so this is again a quadratic equation. What we want to do is definitely move all the x's to one side. So that's a 0.036 x squared. Divide by 0.036. And when you do that, you're going to get 10,000. And take the square root on both sides. So x is going to go at plus or minus, and that's 100. Now, can it be a negative? No, because we definitely are looking at what? The positive side of it. So that's not going to be it. So we just keep the positive 100, okay? Because we're going from 0 to a positive demand, right? You can't sell a negative amount of items. So what's the market price one more time? The market price is the value. I'm going to plug into the S function. So S of 100 is 0.06. 0.006, yes, times 100 squared. So that should be 60, yeah. All right, okay. So one more time, what is the consumer surplus? The consumer surplus is the integral from 0. And again, this time I'm trying not to draw a picture. Let's see if we can pick the right numbers. So it's the integral from, without looking at the formula. So the consumer surplus is the integral from what to what? From 0 to which value? The x value, right? Because it's a dx. So to 100 of, remember the demand function is above, so you start with the demand function, 360 minus 0.03 x squared minus the market price is the bar below, and the market price is this 60. Okay? So it's the integral from 0 to 100. That's a 300 combining like terms minus 0.03 x squared. So the antiderivative of these are 300x minus 0.03 x to the third divided by 3. Plug in a 100 and plug in a 0. Okay, so first of all, when I plug in the 100, it's going to be 300 times 100 minus 0.03 divided by 3 is a 0.01 times 100 cubed. And then again, this time when you plug in the zeros into both these parts, they're both going to be zeros. So put that in your calculator and you'll get a nice and easy 20,000. Okay. And the producer surplus, let's see again if we could figure this out. based on all the examples we've done without looking in the notes or the formula. So it's an integral from 0 to, again, same x value of 100. This time, the market price is the line above, the producer surplus is the below part. So you're starting at the market price of 60 minus the 0.006 x squared. So the antiderivatives of these are 60x minus 0.006 x to the third over 3. Evaluated between 0 and 100. Same thing. The 0 parts are going to turn into 0, so just plug in 100 into both of these, reduce. So see if I came up with 4,000. See if I'm correct. Okay, that should be a 4,000. Okay. So we have a second application in this section, not just consumer surplus and producer surplus, but we have what we call a continuous stream of income. And we're going to revisit this again in 5.9. So what is a continuous stream of income? We already talked, here I'll put it down below, about this function. What function about these formulas? A equals to P times 1 plus R over N to the NT. So we looked at this back in chapter 3 when we talked about investments one more time. So what this formula is about is something called the compound interest formula. In other words, what? If you start with the principal amount of money P, then you invest it at an interest rate R for T years, and the number of compounds per year is N, right? So twice a year, or in other words, semi-annually, or 12 times a year, so in other words, monthly, right? Then after all this time, this principal amount of money at this interest rate and these many compounds will turn into this amount A, right? So we call this the compound interest formula. And then we said, hey, what if we want to compound our money not just twice a year or 12 times a year, but infinitely many times a year, all the time? What does this formula turn into? It turns into what we called the PERT formula. So we call this continuous compound. Okay, that's the continuous compound formula. So what happens in a continuous compound formula? You start with a principal amount of money, P. You invest it at an interest rate R for some time T, which always should be in years. And then you wait, right? So your bank constantly figures out how much interest you've earned and adds it on and reinvests the whole amount. So it's constantly happening that you're starting to earn interest on your amount of interest. But you still sit tight, and what happens at the end of this time? You come up with this amount of money A. Well, what usually happens is that we don't just put a sum of money there and just sit and wait. Maybe after a year, we have a little bit of money again, and we put that into that account as well. So we're adding on to the account. And maybe it's not once a year. Maybe it's every month, right? So maybe your time changes into months. So many times what happens is we are maybe let's say, okay, every month take $1,000 from my paycheck, or every month take $100 from my paycheck and put it into this account, right? So we don't just put a sum at the beginning and sit and wait for the rest of the time, yes? But we keep adding onto the account, and that's exactly what a continuous stream of income is. So the stream of income is also changing. We don't just start with the principal and take our money off, our hands off. It just keeps coming. So suppose a principal amount of money P can earn interest at an annual interest rate R, compounded continuously, right? So that's the E part that's going to come in. And let CFT be a continuous income stream function in dollars per year that applies between year 0 and year T. So we're going to keep it at dollars per year and not per month. So in other words, what? We are starting here, let's start with this future value. We are starting with a continuous amount of money, CFT, that's your principal. But the principal is changing, it's this maybe it's changing, maybe it's a function that's changing. For this section, it'll be constant, right? But you invest it continuously at an interest rate R for a time t. So what happens is it's an accumulative value, right? The first year you earned this much, the next year you earned a little bit more, the next year you earned a little bit more and more and more and more. So what you're getting is you have to use an integral to find that accumulative value in the account in these t years. Does that make sense? So the future value, it's your A, right, that you will get in the future, also called P, principle of the future, is the integral from 0 to t. That's the time that you left the money in there for. And then time is also the variable, right, that keeps changing because, again, every year you might put in a different account, but it's the accumulated value that you have from the beginning till the very end. Now, we didn't quite use this formula much, but I'm going to go back here. Sometimes what we want to do is find how much money do we need to invest now in order to come up with this amount in the future. So what we want to find is what's called the present value. No big deal. We put all the given numbers into this formula and then always solve for the unknown. But I just want to come up with a little bit of formula. So if I wanted to solve for P, for the present value, how do I get to P? Well, I have to take this A and divide it by e to the RT, right? Divide both sides by e to the RT. To make this a little bit prettier, remember what we said. If you have some value with some exponent in the denominator, to avoid seeing that fraction, you can bring that up to the numerator, but what do you have to do with that exponent? You have to make it negative. So this, in fact, is a formula for you to find the present value, knowing the future value. In other words, the amount you want to get to in the future. So this is why the present value, P, there's a formula for that too. If you want to come up with this amount in the future, yes, how much money do you need to invest every year, basically? That's what we're trying to figure out, right? How much should you put in every year in order to get to that? So what we're simply doing is solving this problem backwards, but it's the same, yes, except for you have to have a negative exponent. So here are your two formulas. And by the way, once you found one, you don't need to find the other with an integral. Why? Because this formula simply still applies between present value and future value. So once you have one, you can find the other one simply by using this formula right here. Okay, so let's just see, there's only, oh, there are two problems. Okay, all right, so it says, find the present value of $100,000 due in 10 years, compounded continuously at 5%. So what does that mean? So we want to find the present value in order to come up with 100,000 in the future, and we have 10 years to do so. So the present value, it's, by the way, I don't know, I'm just going to write this again. I've just been used to put consumer surplus and producer surplus. So by the way, no one says that we have a continuous stream of income, right? So all we're doing is just practicing on the formula that I just derived for you. In other words, what? You want to get 100,000 in the future, yes? How much money should you put in now at 5%?